Rupa, good morning. Good morning, everyone. Good morning. So already we have discussed relative velocity, relative motion. Sanjay, I'm good. Sanjay, I'm fine. Yeah. So already we discussed relative motion between the man and rain. Particularly rainman problems we discussed. Even you wrote exam also on that. Okay. So today, Manoj, slowly I'll shout. Don't worry. Okay. So initially my voice will be low as the class going on. So I'll improve it. So what I'm saying is the other important point, the other important part of relative motion is riverboat problems. Okay. So today we are going to discuss riverboat problem. So let us do that. This is entire your kinematics notes. Projection inclined plane. So this is the rain. I think these are the dots. Okay. So we discussed even condition for collision also. Okay, condition for collision also we discussed. So similarly, we can find out the minimum distance between two projectiles, minimum distance between two objects also we can find out. So that we do later. Okay. So first I'll complete the rainman situations. Rainman situation I completed. Next I'll go with the riverboat concept. Okay. No? So it is river boat problems. So what is this riverboat problem? Let us see. Okay. No? So boat will have some velocity. Okay. In the river. So whenever inside the river, suppose that this is the river flowing. The river flows in rightward direction towards right. As the river flows, okay. So river will have some velocity with respect to ground. So that I'm writing as this is the velocity of river with respect to ground. So all of you switch on your videos. Otherwise, you will be sent to waiting room. Then this concept will be very tough to understand. Please switch on your video and stay in the class. Okay. Sir, వీళ్ళందరూ అడ్మిట్ చేస్తున్నా అడ్మిట్ చేశాక మనం మళ్ళీ కాల్ వెయిటింగ్ రూమ్ because Bhavana is there, Girish is there. That's right. Okay. So nobody is there in the waiting room now. Okay. So all of you please switch on your video and stay in the class. If you miss this class, then it is very tough to understand riverboat problems concept. Okay. So today is very, very important class. If you miss all these basics, then you will have problem in solving questions of riverboat concept. So please stay in the class, switch on your video and put your mobile or computer or laptop at one place and sit properly and follow the class. Still, if you switch off your video and sit in the class, they will send to waiting room. Then you don't understand the following classes. Next classes you don't understand. So I'm requesting everyone to switch on your video and stay in the class. If you have any problem with the video, please intimate to host. Okay. Yeah. So I did my responsibility. I told. So next is yours. Okay. So one river is flowing towards right. Okay. You can say that west to east. River flows west to east. So what is the river velocity? VRG is the river velocity. So here what is the terminology? VRG stands for what? Velocity of river with respect to Ground means original velocity of river. Original velocity of river. Okay. Suppose that if a boat is there inside the river, in the river boat is there. In the river boat is there. So boatman is sleeping. So nobody is there inside the boat, let us say. Then boat also will flow with the river speed. Am I right? If nobody is rowing the boat, nobody is driving the boat. Nobody rowing the boat, nobody driving the boat, then boat will move along the river. Then boat velocity will be equal to river velocity. Okay, if any person is there inside, then what is the river velocity as seen by the person? All of you answer this. What is the river velocity as seen by the person? What is the river velocity as seen by the person? Now nobody is rowing the boat. Nobody is driving the boat. So please think all of you once again. So just boat is there inside the river. As the river flows, boat also will move. Boat also will move with the same speed, same velocity. And the river allow flow, the boat would allow move. If any person is there inside the boat, then what is the river velocity as seen by the person? Very good, Manoj. Perfect. Amravati constant, but what is the value I'm asking? Srjc, how much you'll get? Velocity of river minus velocity of person. What is the value? See, boat is just there in the river. Nobody is driving the boat. Nishita, please listen to me carefully. Nobody driving the boat. River is flowing. The boat also follows the river. Srjc is very good. 0. Balaji correct. 0. See, boat velocity is equal to river velocity. Lohit correct. Boat velocity is equal to river velocity because it is there inside the river. That's it. As boat is there inside the river, boat automatically gets the velocity of river. Okay. So I can write down velocity of river with respect to boat man or person inside the boat. Can you see is always 0? Is always 0. As seen by the person inside the boat or as seen by the swimmer. See, boat river boat problems antaru, river swimmer problems and good antaru. Boat place to swimmer discouragement. Boat place lo you can take swimmer also. Okay. Then as seen by the swimmer, as seen by the person inside the boat, the river will have 0 velocity. So this only we call it as VBR. Velocity of boat with respect to river. Velocity of the boat with respect to river and writing. Or velocity of river with respect to boat. Only negative will differ, but remaining things are same. So in this case, it is 0. Not every time, in this case 0, because boat is not rowing. Boat is not rowing by anybody. Boat is at the same time not driving by anybody. So if boatman is driving his boat. So then what would be the driving? Boat driven by the boatman. That is with respect to what? With respect to river. So that's why I wrote velocity of the boat with respect to river, because it is there inside the river. Boatman velocity is always with respect to river, because boatman is there inside the river. Suppose you are there in the bus, you are observing everything. Then everything with respect to bus only, na? Because you are there in the bus. Similarly, boatman is there inside the river. Then whatever he observed with respect to river. So he will maintain one speed with respect to river. That is VBR. Okay. Now let us see the one case. I am writing case 1. If boatman rowing Boatman rowing his boat. All of you listen to this carefully. Rowing his boat downstream. So what is the meaning of downstream? Downstream means this is the velocity of river with respect to ground. Velocity of river with respect to ground. Velocity of river with respect to ground. Now how the boatman is going now? So similar things we have done. Now boatman is rowing his boat along the river direction. Along the river direction, boatman is rowing his boat. Along the river direction, boatman is rowing his boat. Then what will be the boat velocity as seen by the person on the ground? What is the velocity of the boat as seen by the person on the ground? All of you think about it. What is the velocity of the boat as seen by the person? Yes, Jaydesh. River and boat both are in the same direction. Whenever both are moving in the same direction, then it we call it as boatman is going downstream. Correct location really. Downstream. Manoj, downstream means boat is moving along the river. River flow along the boat could allow move. That's called as downstream. Downstream means boat is rowed along the river. Along the river current, you can write down if you want. River current means river speed. Current means speed. Okay. Then see, already we know that VBR is equal to VBG minus VRG. I can write down. So again, I'm applying the relative velocity formula. Correct, Bhavana? Yes, most of the people have answered correct. So I'm applying the direct formula of relative velocity. What is the VAB bar is equal to VA bar minus VB bar. So VBR bar is velocity of boat with respect to river is velocity of the boat with respect to ground minus velocity of river with respect to ground. Then what is the velocity of the boat with respect to ground is velocity of the boat with respect to river plus velocity of river with respect to ground. You have to go for resultant of these two. So what is the velocity of the boat as seen from the ground? Velocity of boat as seen from the ground. You have to add velocity of the boat plus velocity of the river. Simple logic is use common sense. Think from the common sense. River is flowing. You are there in the river means river will push you along its direction. Am I right or not? So if you are moving in the river direction, it will help. If you are moving opposite to the river direction, it will oppose. Okay. So as both are in the same direction for downstream. So what is the velocity of the boat as seen from the ground? The magnitude of velocity of the boat as seen from the ground is magnitude of velocity of boat with respect to river plus velocity of river with respect to ground. You can add magnitudes. Okay. You can simply add magnitudes. Similarly, can you find out if boatman rowing his boat upstream? If he is moving upstream, upstream means opposite to river flow. All of you try for upstream, opposite to river flow. Who is this? Srjc, why you got doubt with the telescope? First, let me know. Because telescope will have some lenses. Because of lenses, velocity of the object will change. Okay. So obviously it will change. But you have to know telescope logic. Girish. Girish, Girish.
Sir, doubt, sir. If boat man is rolling in his boat downstream another, sir. Hardness, sir. Hardness.
Downstream అంటే బోట్ along the boat పోతున్నాడు అదే along the river వెళ్తుంది బోట్ మనం డ్రైవ్ చేస్తుంది కూడా along the river ఎలా ఉంటే మనం బోట్ కూడా అలానే డ్రైవ్
అదే సార్ అక్కడ VBR equal to VBG minus VR1 సార్
VAB relative velocity రా మర్చిపోయాను relative velocity లాస్ట్ వీక్ అంతా అదే చేసాం VAB బార్ రాసాం VAB bar velocity of A with respect to V VA bar minus VB bar.
Okay, sir.
అప్పుడు VBR అంటే ఏంటి అవుతుంది velocity of boat with respect to river కదా velocity of boat with respect velocity of boat with respect to river అంటే మీనింగ్ ఏంటి velocity of boat minus velocity of river కదా velocity of boat minus velocity of river. We are just using the relative velocity concept. So velocity of boat as seen from the ground is equal to velocity of boat as seen from the boat, I mean with respect to boat plus velocity of river with respect to ground.
Yes, sir.
Girish, అర్థమైందా?
అర్థమైంది సార్.
So just I'm using the relative velocity concept, nothing else. Velocity of A with respect to B is velocity of A minus velocity of B. Velocity of A with respect to ground, velocity of B with respect to ground. Okay. Next we go with the case 2. What the case 2 is? If boatman rowing his boat upstream. What the upstream means? See, let us say river flows in this direction. This is the VRG. River flows towards right. River is flowing towards right. West to east. You can say that west to east. If river flows west to east with what velocity? VRG bar. The meaning of VRG bar, velocity of river as seen from the ground, means original velocity of river. Now boatman is rowing his boat. Boatman is rowing his boat. Boatman is rowing his boat with a speed of VBR. See, what is the VBR? VBR is the speed or velocity maintained by the boatman. Velocity absorbed by the boatman. Boatman is there inside the river. So definitely he will see some other speed as seen from the ground. He will see some other speed as seen from the ground. Okay. All of understanding this. See, you are in the river. You are rowing his boat. You are rowing a boat. You are having the motor boat. You are driving your boat opposite to river. You are driving your boat opposite to river. Suppose your friend is standing on the ground. Your friend is standing on the ground. Then will he see the same speed? మీరు వెళ్తున్న స్పీడ్ మీ ఫ్రెండ్ కనిపిస్తుందా as you are moving opposite to river flow? No, you will see the less speed. Correct, very good. He will see your friend will see the less speed, but you will feel that you are going with the more speed. So why there is a difference? Because river is flowing and you are moving opposite to river flow. You are moving opposite to river flow is called as upstream motion. You are flowing opposite to river flow is called as upstream motion. Okay. Then what is the velocity of the boat as seen from the ground? If any person observes from the ground, what is the velocity of the boat? Velocity of the boat with respect to river is equal to velocity of the boat with respect to ground minus velocity of river with respect to ground. So this particular term, this vector will tell you velocity of the boat as seen from the ground. Okay. So that's why we require VBG bar. VBG is equal to, I can write down VBR plus VRG. So resultant of these two velocities. Resultant of those two vectors will tell you velocity of the boat as seen from the ground. How the boat is moving as seen from the ground. Okay. How it's understood? So then as seen from the ground, what is the velocity? What is the magnitude of velocity of the boat as seen from the ground? I can write down velocity of the boat with respect to river minus velocity of river with respect to ground. Provided velocity of the boat with respect to river is more than velocity of the river with respect to ground. So when he can actually move upstream, he can move upstream when his boat velocity is more than river speed. Saitija, obviously, no, both vectors are opposite. See, Saitija, you use the vector logic also. We are missing vector logic. Both vectors are opposite, and we want to find out the resultant. Then obviously we have to go for subtraction. So you should not think like opposite minus. It's not like that. Go with the vectors now. Always think from the relative velocity vector subtraction. Even when I started relative velocity, I told you also. You have to think about the vector subtraction. If you think from the vector subtraction, you can solve the questions easily, and you will understand all the things. Vector subtraction and vector resultant. Okay. So what is the example for these two situations? All of you wrote down? Anybody writing? Completed. Okay. Yeah, mine is also completed. Okay, Ganesh is also completed. Okay, Vishnu has been also completed. Yeah, most of the questions completed. Let us go with some examples of these two, upstream and downstream. Suppose river is flowing with 4 meters per second. River flows with 4 meters per second. Let us say one boatman is rowing his boat at 10 meters per second in the same direction. Then what is the velocity as seen by the person on the ground? 14. You have to add. That is the meaning of downstream. It's very easy one. Okay, na? Boat ki actually 10 undi, but river kuda 4 meters per second to flow up and boat ka velocity added. Okay. Then what is the velocity of the boat as seen from the ground? Will be 10 plus 4, which will be 14 meters per second. Suppose that same boatman took a turn. Now he took a U-turn. Now boatman is moving opposite to river flow. with 10 meter per second. Exactly. So he will feel that the person, see here, all of you listen to me. 6 is not the, 6 is the answer, but that is not important. What you have to understand is, boatman feel that the person inside the boat, or the driver of the boat, okay, driver of the boat or person inside the boat will feel that he is moving at a speed of what, 10 meter per second. But the person on the ground will see that he is moving. Person on the ground will see that he is moving at a distance of what? At a speed of what? 6 meter per second, 10 minus 4. Because now river will oppose me. As the river is opposing him, then its speed automatically comes down. Here river will support. In the first case, river will support. In the second case, river will oppose. So this is called as downstream. And this is going against the river. It's called as upstream, not upward. Okay, na? So same terminology you will see in the questions also, downstream and upstream. Now I will give one more example. I think with this example you will understand better. Now river is flowing with 10 meter per second. River flows with 10 meter per second. Let us say this is the one line. Okay, boat is started. Now there is a boat. Boat is going upstream and maximum speed of the boat is 4 meter per second. Maximum speed of the boat is 4 meter per second. Now tell me, boat will go upstream or downstream? Now what is the velocity of the boat and in what direction boat will move?
Downstream.
Very good. I think Safalia answered upstream. Safalia once verify. Boat velocity is very less, but river velocity is very more. River velocity is very more and boat velocity is very less. So then boat does not go upstream, it will go downstream. Okay, na? So it will go downstream with what speed? 6 meter per second. Very good. Very good. Okay, so this is all things you can understand from the relative velocity also. You can do relative velocity. You can easily go with VBZ. As seen from the ground, the person on the ground will see that boat will go downward with what speed? With 6 meter per second. Safale boat is having the very less speed, but river velocity is very more. The river will push him, no? River will push the boat with 10 meter per second. You are there in the flowing river. You are there in the flowing river, means you cannot stay at one place. You cannot stay at one place. You will flow along the river. River ke velocity no equal ade velocity vastundi. So boat equal enta velocity vastundi 10 meter per second vastundi downward. Boat also will get 10 meter per second downward speed. Automatically it will come. But boat velocity is 4 upward. The resultant will be 6. Resultant will be 6 in downward direction. So boat cannot go upstream. It will go downstream, even though it is trying to move upstream. Because river velocity is very more comparatively boat velocity or boat speed. Properly understood? Okay. So this is upstream and downstream motion. So let us go with now across. Case 3. All of you wrote down, anybody writing? Anyone want to copy this? Okay. Okay, completed. Very good. Next, case 3. What is the case 3 is? Now, boatman is not going upstream and downstream. He want to cross the river. Okay, na? Boatman wants to cross the river. So that means he want to move from one bank of river to other bank of river. Clear? So something like this. This is the river. Okay. So usually water is light blue. Let us take light blue. Suppose water flowing towards right with what speed? Obviously with the speed of VRG. Okay, now river is flowing towards right. Now boatman started at A point. Boatman started at A point. River is flowing with velocity VRG in rightward direction. Hope everybody is following you. Okay. Boatman started at A point. Now he want to reach the B point. He want to reach the B point. Suppose if he is moving perpendicular to river, if he is rowing his boat perpendicular to river, will he reach the B point or not? See, he is driving his boat or he is rowing his boat perpendicular to river. Perpendicular to river. Who is the, please wait, we will discuss all the things. Okay. So as he is rowing his boat perpendicular to river to reach the B point. So boatman feel that he will reach the B point. ఎందుకంటే పర్పెండిక్యులర్ గా రోల్ చేస్తున్నాడు కదా, పర్పెండిక్యులర్ గా బోట్ డ్రైవ్ చేస్తున్నాడు. బోట్ మ్యాన్ కి ఎలా ఉంటుంది డ్రైవ్ చేసేవాడికి? ద పర్సన్ ఇన్సైడ్ ద బోట్ విల్ ఫీల్ దట్ హీ ఈస్ గోయింగ్ టు రీచ్ ద బి పాయింట్, బట్ విల్ హీ రీచ్ ద బి పాయింట్ ఆర్ నాట్? No. Very good. So at what point he might reach? Which point he may reach? Name Purushottam. Okay. Yeah, on the right side of B point, somewhere, because of river flow. See, he is moving in proper way. Perpendicular to river, he is moving so that he want to reach the B point. But because of river velocity, what will happen? River will push the boat in rightward direction. Then ultimately he will reach some other point, C. He will reach the C point. So that means A to C is the path seen by the person on the ground, but A to B is the path assumed by the person inside the boat. So this is the VBR. This is the VBR vector. This is the VRG vector. I told you, no, what is the velocity of boat with respect to river is equal to velocity of the boat with respect to ground minus velocity of river with respect to ground. Then what is the velocity of the boat with respect to ground is equal to velocity of the boat with respect to river plus velocity of river with respect to ground. So resultant of these two vectors, this is one vector and this is other vector. Resultant of these two vectors will be the velocity of the boat with respect to ground. Okay, so that means this is the path. This is the path of boat. Path of boat as seen by person. As seen by the person on the ground. The ground person will see that boat is moving at an angle. But this is the path. This is the path. Path of boat as seen by person inside the boat. Okay, boat lo ఉన్న ఎలా కనిపిస్తుంది? Boat AB direction వెళ్తున్నట్టు కనిపిస్తుంది. But actually because of river velocity, boat will be seen along the AC line. Ground లో చూస్తే AC లో కనిపిస్తుంది, but boat లో చూస్తూ ఉంటే AB లో కనిపిస్తుంది. So that is the idea of relative motion. As observer changes, motion of the object also changes. Understood? So like this, boatman will travel in one direction. Okay, boatman will feel or boatman will try to move in one direction, but actually boat will go in other direction as seen from the ground. Ground lo chuste oka direction untundi, boat lo chuste oka direction. Okay. So I'll ask you one more common sense question. So all of you try this. Okay, again, this is the river. River flows in rightward direction. Okay, river is flowing in rightward direction. VRG bar. Now boatman is starting at A point. Now he want to reach the B point originally. Finally, B point reach avalanthukondi. He want to reach the B point. Then how he has to drive his boat? How he has to row his boat? What is the direction? In what direction if he row his boat, he will have a chance to reach the B point. Okay. So I'll give you some directions. You choose them. Choose one of them. Okay. This is the one direction, second direction, third, fourth, and fifth. So what are the possible directions? Very good. So in which direction boat can be rowed so that he will reach the B point?
4.
4 or 5. Can be anything. It all depends on other conditions. That mathematics we will discuss. Not on Bhupesh, not only 4, it can be 5 also. Vishnuvardhan, not only 4, it can be 5 also. Ultimately, he has to row his boat upstream. Upstream ante exactly opposite to velocity kaadu. So, I mean, what do you say that in the opposite to river flow at an angle? Either 4 or 5. If we go along the 4 or 5, he will have a chance to reach the B point. So, under what conditions he will reach the B point, that we see later. Okay. If he is rowing his boat perpendicularly, he won't reach the B point. He will reach some other point.
C point.
If he is rowing his boat at some angle, then he will reach the B point. That means he has to aim some other point. Let us say he is aiming the C point. If he is aiming the C point to reach, then he will reach the B point. Understood? If boatman is aiming to reach the C point, he might or may reach the B point. All of you understood this idea? Clear? And very important thing is this. Try to understand this part. Resultant of velocity of boat with respect to river plus velocity of river with respect to ground will give you velocity of the boat as seen from the ground. Okay, all of you write down the case 3 and try to understand the logic behind it. As boat is there in the river will push the boat along its direction. River ela flow aithe ade direction lo boat ni kuda push chestundi. So that's why boatman oka path chuste ground lo ఉన్న వాళ్ళు ఇంకో path చూస్తారు. Okay, all of you wrote down. Completed, okay. Okay, so in this case 3 also we will have so many cases. All of you wrote down, no? Anybody writing? All of you wrote down? Okay. So now I'm taking the same thing, same discussion. There is a river. River flows towards right. Okay. So river is flowing towards right. Wait, we discuss. We are going to discuss all the things. Huh? Okay. So I think already it was. Now, Girish, copy this. Saiteja, location, all these people know Bhavana, Larry, Ram Shankar, Purushottam. So all these people knows already. I discussed last time. Okay, wrote down, Girish. Girish, okay na? Sure. So now, let us go with the concept as the river is moving towards right with velocity VRG. Now, boatman is started at A point, rowing his boat at some angle. This is the VBR. How the VBR vector is? So, boatman is rowing his boat along one direction. So, that means he is aiming the some point C, let us say. C is the point. So, will he reach the C point? No, obviously, he does not reach the C point because of river flow. He will reach the some other point other than C. C కాకుండా ఏదో point reach అవుతారు వాళ్ళు. Am I right? Now boatman is making an angle theta with the line perpendicular to river. Boatman is making an angle. Boatman is making an angle theta with the line perpendicular to river, and width of the river is W. W is the width of the river. Okay. Now, as seen from the ground, see now I'm discussing everything with respect to ground. So if I see with respect to ground, so person is there on the ground, he is observing the things. The person on the ground is observing the things. So every calculation is done by the person on the ground. Okay. So then what is the velocity of the boat as seen from the ground? Velocity of the boat as seen from the ground is velocity of the boat with respect to river plus velocity of river with respect to ground. So that means resultant of these two vectors. So boat will have velocity of the river with respect to ground, velocity of the boat with respect to river also. Both velocities will be there for the boat. Boat own velocity is VBR. VBR is the boat own velocity. Boat is there inside the river. River is flowing with some velocity. Then boat also will get the same velocity. And a boat ki river velocity ఉంటుంది, own velocity కూడా ఉంది. రెండు ఉంటాయి. Okay. So we have to find out the resultant of VBR and VRG. But we are not going for resultant of root of A square plus B square plus 2AB cos theta. We are not doing in that way. We want to do in two dimensional. I'm taking this is x-axis, let us say, and this I'm taking as y-axis. Across the river y-axis, along the river x-axis. Two dimensions I want to make. Now I'm going to make the components of VBR. I'll take this component as VBR cos theta. And what the other component is? VBR sin theta. Okay. One is VBR cos theta, other one is what? VBR sin theta. Okay. Now, how many velocities are there for the boat? How many velocities are there for the boat? Now, boat will have how many velocities? No location will be not. 2 VBR and VR. Very good, Saitya. It will be 3 now. ఇంతకు ముందు ఎన్ని వెలాసిటీస్ ఉండేవి? రెండు. ఒకటి విఆర్జీ, ఇంకోటి ఏమో విబిఆర్. ఇప్పుడు ఎన్ని ఉంటాయి? 3 ఉంటాయి. ఒకటి విఆర్జీ, ఇంకోటి విబిఆర్ కాస్ థీటా, థర్డ్ వన్ ఇస్ విబిఆర్ సైన్ థీటా. 3 velocities will be there. మనం VBR ని 2 parts చేసాం. VBR cos theta and VBR sin theta. Okay. So now boat will have 3 velocities. One is VRG, second one is VBR cos theta, third one is VBR sin theta. Okay. Now 3 velocities are there. Now my question is, what are the importance of these three velocities? Because of VRG, see, now boat is having, this is the boat, let us say. So towards right, what is the velocity is there? VRG. Towards left, what is the velocity is there? VBR sine theta. And across the river, perpendicular to the river, what is the velocity is there? VBR cos theta. Now, what is the importance of all these three velocities? Because of VRG, boat will try to move towards right. All of you listen to me carefully. All of you listen to me. Stop writing and listen to me. Because of VRG, boat will try to move towards right. Because of VBR sin theta, boat will try to move towards left. Because of VBR cos theta, boat will try to move across the river, perpendicular to the river. Location, wait, I'll discuss all this. Now, my question is, because of which component of velocity, boat is able to cross the river? Because of which component of velocity, boat is able to cross the river? Very good, Bhavna. Very good, very good. Very good, everybody. Yes, correct. Lloyd, very good. Lloyd, which component, sine or cos? Only one component. Because of VBR cos theta. Because of VBR cos theta, it is able to move along the Y. Correct, Safali. Because of VBR cos theta, it is crossing the river. So, what is the time taken to cross the river? What is the time taken to cross the river? Anybody? So time taken to cross the river. I want time value. With what speed it will cross the river? With VBR cos theta. And what is the width of the river is? What is the distance of the river? To cross the river, how much distance it has to travel? W is the distance. Distance by time. Distance by time we call it as speed. Time is equal to distance by speed we can write down. So this is W by VBR cos theta. So many people are answered already. Very good. This is the time taken to cross the river. Okay, na? So one thing we got. What is that? In what time the boat is crossing the river? What is the next thing we require? Whether it will move or whether boat will reach the O point or some other point. Okay. So we want to find out those conditions. For that, what I'm writing is, I'm writing three statements. All of you try to think about it. The first one is, if VRG is equal to VBR sin theta, VRG is equal to VBR sin theta, then boat will reach opposite point. Boat will reach opposite point O. O point reach out. A point just start out. A point opposite point enti O. O reach out the boat. Boat actually O reach out. When VRG is equal to VBR sin theta. Second case, if VRG is more than VBR sin theta, VRG is more than VBR sin theta, then boat will reach some point. Boat will reach some point on the which is right side of O. Okay, it will reach some point of right side of the O. Okay. When VRG is more than VBR sin theta. The third statement is, if VRG is less than VBR sin theta, then boat will reach some point. I think some of you I think understood. Remaining people, please think what I'm writing. Okay, some point which is left side of correct. Okay. So once you understood these three conditions, then river boat questions mostly you can solve, provided you require practice. There are three statement of say question solve aguntante alakadu. If you require practice also and right way to understand the question also. Okay, all of you write down and think. So there are three velocities. Towards right of velocity, towards left of velocity. Okay, and across one velocity is there. Across VBR cos theta is there. Okay, all of you wrote down. Anybody writing? No, location it's not like that. See, if theta is the angle maintained, then W by VBR cos theta. In all cases, theta won't be same. If theta is same, you will get only one case. No, why you will get three cases? As the theta changes, you will get three cases. Okay, equal, less, and more. W is nothing but width of river, severity. W stands for width of river. Time on I'm saying, location I'm saying the time. Time formula is same, W by VBR cos theta. But any case for theta same ఉండదు కదా. Theta same ఉంటే మూడు కేసులు ఎందుకు వస్తాయి? రావు కదా. త్రీ కేసెస్ వస్తున్నాయంటే theta చేంజ్ అవ్వాలి లేదంటే VBR చేంజ్ అవ్వాలి. Location at either VBR changes or theta changes. Then only you are getting the three cases, equal, less, and more. Don't think that any case for time value same. Time formula is W by VBR cos theta. మీరు మెయింటైన్ చేస్తున్న theta value, మెయింటైన్ చేస్తున్న VBR value రెండు రాసుకుంటే time value వస్తుంది అంతే. Okay. So don't think that in all cases time value is same. Time formula is W by VBR cos theta. But as the theta changes or VBR changes, you are getting three different cases. Let us see the first case. Okay, no? See what is the VRG and what is the VRG and VBR sin theta importance. VRG will try to move the boat in rightward direction. VBR sin theta will try to move the boat in leftward direction. Am I right? VBR cos theta will try to move the boat across it. So now let us go with the first case. All of you wrote down, anybody writing? Okay, in first case, if VRG is equal to VBR sin theta. VRG is equal to VBR sin theta. That means what? See, both has VRG in rightward, VBR sin theta in leftward. Both velocities are equal and opposite. Means both will cancel out. Velocities are equal and opposite. Cancel out together. They will cancel each other. They will cancel each other, and both won't move rightward or leftward. Both rightward move or leftward move. But it is having the VBR cos theta. VBR cos theta is there. Because of VBR cos theta, it will move perpendicular to river. And if it is starting at A point, which point it will reach? It will reach B point. Okay, no? Both reaches, already we wrote, reaches the opposite point. Okay. So this case we call it as drift value is equal to 0. What is the meaning of drift? Drift means, see, wait a minute. See, opposite point is B. You see this diagram. See this diagram. Okay. Opposite point is B. Then boat is reaching the C point, let us say. The distance of the point where it is reaching from the opposite point we call it as drift. Drift means that is the distance dragged by the river. Okay. Drift is nothing but what? Distance of the point where boat is reached from the opposite point. If you want to write down, somewhere. Drift is nothing but what? Distance of the point. Distance of the point where boat is reached from opposite point. The distance we call it as what? We call it as drift. Okay, you write down somewhere in your notebook if you want. If you understand, no need. So I think by this time you understood. It is very important to understand first, then writing. Next thing is writing. The third important thing is to revise. And fourth important thing to remember. Okay. Understanding, writing, okay, revising and remembering. UWRR. UWR square phenomenon. Triple R movie గుర్తుంటుంది కానీ ఇలాంటి గుర్తుందా? Okay, wrote down a drift. Devanand Reddy, wait, we'll discuss. Everything we discuss, huh? Opposite point. Distance of the point where boat is reached from the opposite point. Opposite point. Okay, that distance we call it as drift. Huh? Manoj, okay? Now in this case we are reaching directly B point. As we are reaching the directly B point, what is the drift value? 0. Drift and is the distance of the point from the B point, where it is reaching. Boat arrow point reach out there. That point distance from the B is called as drift. But here now we are directly reaching the B point. That means we are experiencing the 0 drift. But boatman is aiming at what angle? He is aiming at an angle theta with the perpendicular line. He is aiming, he is moving at an angle theta with the perpendicular to the river. He is not aiming the B point, he is aiming some other point. Okay, are you getting that idea? Please observe all the things. Then questions can be understood easily and solved. Okay. Okay. Laptop is running with low battery, huh? Yeah, it's getting charged. So clear? So he is aiming at some other point C, but he is going to reach the B point. So to reach the B point, he has to maintain particularly angle. See, once what is the condition to reach the B point now? Now we found one condition to reach the B point. What are the conditions? The condition is VRG is equal to VBR sin theta. Then what is sin theta is equal to? Sin theta is equal to VRG by VBR. Sin theta is equal to what? VRG by VBR. Or theta value you can write down sin inverse. Theta value you can write down sin inverse VRG by VBR. So this is the angle maintained by boatman with perpendicular line to the river, with perpendicular line, so that he will reach the opposite point. Okay, so you have to maintain particular angle according to the boat speed. Here, VRG we cannot change. River velocity we cannot change. River velocity will be fixed. If you are taking a river will flow with the same velocity. What velocity we can change? We can change the boat velocity. Boat velocity we can change. So suppose one boat is moving this particular velocity, then it has to maintain some angle. What angle it has to maintain? Sin inverse VRG by VBR. So to apply this formula also we have one condition. So this is possible. Again, the situation is possible. This is possible when VRG is less than VBR. VRG is less than VBR or VBR is more than VRG. You can write down VRG is more than VBR. That's it. VBR is more than VRG. That means boat velocity should be more than river velocity. When boat velocity is more than river velocity, then only it is possible reaching the opposite point. Okay, na? Reaching the opposite point is possible when boat velocity is more than river velocity. So I can make a note here. If boat velocity is less than river velocity, boat velocity is less, river velocity is more. So same as downstream I told you. Equal also you can take, but theta value is 90. Theta 90 is not an what is it? Not an accepting value. Theta 90 means what? You are moving opposite to river flow. Theta 90 at opposite to river flow move opposite point you cannot reach. Okay, so that's why it should be less. I mean, VRG will be less than VBR. Our boat velocity should be more than river velocity. Okay, so when boat velocity is less than river velocity, at any circumstances, boat has to move along the river only. Because river velocity together, then river will push the boat more. Then boat moves. Then boat will go along the river. Okay, so then if VBR is less than VRG, then boat never reach the opposite point for any angle. You can keep any angle, but boat never reach the B point. Opposite point cannot reach. Because theta value you get more than 1. I mean, sin theta value more than 1 you get, which is not possible. And from logic also, or common sense also, we can say boat velocity is less, river velocity is more. Then he has to go along the river. Just like I told one case, 10 is the river velocity and boat velocity is 4 meters per second going upstream. I've given that example also. See, along with the physics and mathematics, sometimes you have to think from your common sense also. Boat is తక్కువ velocity ఉంటే along the river flow అవ్వాల్సిందే boat. So we know the condition to reach the opposite point. What the condition? Sin inverse VRG by VBR. If boatman is maintaining this angle, definitely he will reach the B point. Which is zero drift. Can I say this is the minimum path followed by the boat to cross the river? Minimum path followed by the boat to cross the river, I can say. All of you think. See, we are starting at A point by taking the minimum distance, minimum path. మనం తక్కువ డిస్టెన్స్ ట్రావెల్ చేయాలి, ఓవర్ దట్ రివర్ని క్రాస్ అవ్వాలి. అంటే బోట్ ఎలా వెళ్ళాలి? how the boat should travel. Boat has to cross the river with minimum path length or minimum road shortcut అన్నమాట. రోడ్ లెంత్ తక్కువ ఉండాలి, పాత్ లెంత్ తక్కువ ఉండాలి, మినిమం ఉండాలి, బట్ బోట్ రివర్ని క్రాస్ అవ్వాలి. దెన్ బోట్ హ్యాస్ టు మూవ్ పర్పెండిక్యులర్ టు రివర్. బోట్ పర్పెండిక్యులర్ టు రివర్ క్రాస్ అవ్వాలంటే, మూవ్ అవ్వాలంటే బోట్ మ్యాన్ హ్యాస్ టు మెయింటైన్ సమ్ యాంగిల్. వాట్ ఇస్ ద యాంగిల్? sin θ is equal to VRG by VBR. Okay, see, this is the VBR, no, actually this is the VBR. What does it mean? So boatman is aiming the C point. So this is the path by boatman, and that and the path seen by the boatman. So this will be the what? Path by ground person. See, in simple terms I'm writing. With respect to ground, this is the path. So this is the actual path. AB is the actual path followed by the boat. AC is the path assumed by the boatman. Boatman అనుకుంటా ఉంటాడు బోట్ AC path లో వెళ్తున్నాడు, బట్ యాక్చువల్గా బోట్ ఏ path లో వెళ్తుంది? AB path లో వెళ్తూ ఉంటుంది. VPC is the real, VBR is the assumed one. Okay, zero drift case is nothing but minimum path followed by the boat to cross the river also. Both the cases are reaching the opposite point. The question align on it. What is the angle maintained by the boat person to reach the opposite point? What is the angle maintained by the swimmer to get the zero drift? He has to move perpendicular. వాడు ఎలా మూవ్ అయితే అలాగే కనిపిస్తుంది. అయితే వాడు ఎలా మూవ్ అయితే అలాగే ఎలా కనిపిస్తుంది. వాడు అనుకోవాలి పర్పెండిక్యులర్ రివర్స్ లో వెళ్తూ ఉంటాడు అంతే. బోట్ని ఎలా నడపాలని వాడి ఇష్టం, అది మనకు సంబంధం లేదు. కానీ బోట్ ఎలా వెళ్తుంది అనేది రివర్ వెలాసిటీ మీద డిపెండ్ అయి ఉంటుంది, అది మనం చూస్తాం బయట ఉంది. సో గ్రౌండ్ లో ఉన్నవాడు బోట్ మ్యాన్ వెలాసిటీ, రివర్ వెలాసిటీ రెండింటికి కాంబినేషన్ రిజల్టెంట్ చూస్తాడు. బోట్ మ్యాన్ వాడు ఎలా వెళ్ళాలనుకుంటున్నాడో అలా వెళ్తూ ఉంటాడు. బోట్ అలా రోల్ చేస్తూ ఉంటుంది, బోట్ అలా డ్రైవ్ చేస్తూ ఉంటాడు. పర్పెండిక్యులర్గా వెళ్ళాలనుకుంటే పర్పెండిక్యులర్గా వెళ్తూ ఉంటాడు. Then he won't reach the B point, he will reach some other point. Okay, minimum path, zero drift, and reaching the opposite point, all are having the same logic. Anni okate. Okay, he has to maintain some angle with the line perpendicular to river. That angle is equal to sin inverse VRG by VBR. Others okay? Wrote down. Complete data. Anybody writing? Completed. Okay. So let us go to the next case. What the next case is? If VRG is more than VBR sin theta. VRG is more than VBR sin theta. Then what happens? See, now boat is starting from A point. Now because of VBR cos theta, it will cross the river. Means it will move perpendicular to the river. Now VRG is more than VBR sin theta, no? Then resultant velocity I can write down towards right, which is VRG minus VBR sin theta. Because VRG and VBR sin theta both are opposite vectors. What is the resultant? We have to subtract. How we have to subtract? Higher value minus lower value. Higher value minus lower value will be the resultant. Within the A bar and B bar, which are perpendicular, are opposite each other, 180 angle. Then what is the resultant of A bar plus B bar, which is A minus B or B minus A. Am I right? I think all of you remember that. So now how the boat will move? So definitely boat does not reach the B point. Why? There is a velocity towards right. Because of rightward velocity, boat will travel rightward. Even because of VBR cos theta, boat will cross the river. So that means what the resultant velocity will be at some angle and will reach the C point. So this AC will be the what? AC will be the VBG, velocity of the boat as seen from the ground. As seen from the ground, boat will move along the AC path. AC is the path traveled by the boat as seen from the ground. Okay, but boatman will maintain some angle with the line perpendicular to river. Under this condition, what happens? There is a drift. So in this case, obviously theta, see case 1 theta, case 2 theta will be different. And theta and theta smart down. Theta smart equality will become greater. See, when the VRG is equal to VBR sin theta angle, we got some angle theta వచ్చింది. మళ్ళీ ఇక్కడ VRG greater than VBR sin theta అవుతుంది కదా same angle కి. Angle has to change. Angle has to decrease. Angle decrease అయింది అనుకోండి, VBR sin theta will decrease. అప్పుడు VRG will be more than VBR sin theta. So theta is not same, but we are writing as theta. Then what is the time taken to cross the river? What is the time taken to cross the river? Still we can write down W by VBR cos theta. Width of the river by perpendicular component. That's it. You can remember in that way. Width of river by perpendicular component. Okay, don't think that time value is same in both the cases. Theta is not same, no? But we are writing as theta. Try to understand. Then what is the drift value? Can you find out the drift value? Drift is nothing but displacement along the x-axis. You can take this is x-axis and this is y-axis. Okay. What is the drift is nothing but displacement along the x. It's something like a projectile motion. Can anyone tell me what is the drift value now? So what is the drift, which is nothing but BC length is equal to. Drift is nothing but horizontal displacement only, na? BC is nothing but horizontal displacement. Then horizontal velocity. Horizontal velocity into time taken. Horizontal velocity into time, because no acceleration here. In this concept, no acceleration here. First, we learn with the velocities. Then, if you want, you can go with the acceleration. Acceleration means it will be a little tough. Okay, so then I can write down VRG minus VBR sin theta multiplied with the time, which is nothing but W by VBR cos theta. So this is the drift. JNPD, please follow me. Okay. You're doing something. You are saying something. This file is something different. Okay. So both will reach. Both will have drift rightward and right. When VRG is more than VBR sin theta, both will have drift in rightward direction. And the drift on the right side. So now you can write down case 3 also, everybody. When VRG is less than V by sin theta. If VRG is less than V by sin theta, then you can check what is the condition, where the boat will reach, what is the time taken to cross the river, what is the drift value. Aditya, are you concentrating? From last 15 minutes, you are very happy and laughing. Aditya, 21011. Aditya. No response. You're doing something, not following the class. Aditya, 21011. Aditya, are you there? You are there, but respond to me. Aditya, are you following? Aditya, 21011. Okay, all of you wrote down. Write down the third one also. Third condition also write down. If VRG is less than VBR sin theta, see what will happen. All of you write down in your notebook, in your own. You realize the second version of the third round. Correct word. Word correct. Sanjay, you wrote down. Sanjay, you wrote down the third case. Writing now. Okay.
Hello, sir.
Yes.
Sir, you unmute me. Why, sir?
అరే ఆదిత్య వై ఏంట్రా నేను కనీసం 15 minutes నుంచి పిలుస్తూనే ఉన్నారు ఆదిత్య ఏం
సార్
చేస్తారు
నెట్వర్క్ ఇష్యూ సార్ అన్మ్యూట్ మీద వస్తాండి అది కావట్లేదు సార్
లేదురా నువ్వు రెస్పాండ్ కాలేదు
అది అన్మ్యూట్ మీద వస్తూనే ఉన్నా సార్ దాని నుంచి
ఓకే ఏం 15 minutes నుంచి ఏంటి బాగా హ్యాపీగా ఉన్నావు నవ్వుతూ ఉన్నావు జోక్స్
లేదు సార్ నేను వస్తూనే ఉన్నా సార్ అది రావట్లేదు
దాని గురించి కాదురా ఒక 15 minutes నుంచి నువ్వు చాలా హ్యాపీగా ఉన్నావు నవ్వుతూ ఉన్నావు ఏంటి వాట్సాప్ లో ఏమైనా జోక్స్ వస్తున్నాయి
ఏం లేదు సార్
మరి ఫాలో అవుతున్నావు క్లాస్
ఎస్ సార్ రైటింగ్ సార్
నువ్వు రైటింగ్ అని అడగలేదురా నేను ఫాలో అవుతున్నావు అని అడిగా
ఫాలో అవుతున్నా సార్
పక్కా అడిగితే చెప్తా ఆన్సర్ ఏమైనా క్వశ్చన్ అడిగితే ఆన్సర్ చెప్తావా అని అడుగుతున్నా
చెప్తాను సార్
అడిచా ఉన్నావా ఓకే Okay. So what is the third part is? Third part is if VRG is less than VBR sin theta. If VRG is less than VBR sin theta, then what will happen? Now VBR sin theta component is more than VRG. So finally, you cannot add VBR sin theta and VRG. VRG and VBR sin theta add చేయలేవు. Why? Because they are opposite. Opposite ఎప్పుడు యాడ్ అవ్వవు. ఎందుకంటే రిజల్టెంట్ ఫైండ్ చేస్తున్నాం మనం. ఆపోజిట్ వెక్టర్స్ ని యాడ్ చేస్తున్నాం కదా, మాగ్నిట్యూడ్స్ యాడ్ కావు, ఇప్పుడు సబ్ట్రాక్ట్ అవుతుంది. If VBR sin theta is more than VRG, then both will have VBR sin theta minus VRG in leftward direction. Leftward లో VBR sin theta minus VRG ఉంటుంది. So this is important. That is correct. So now what is the other velocity? VBR cos theta. With this velocity, it will cross the river of width W. Okay. So then I can write down. Both will have drift. So now velocity is there leftward. Velocity is there leftward. So both will have drift leftwards. Okay. No? Then what is the time taken to cross the river? Time taken to cross the river is equal to W by VBR cos theta. As I told you, అన్ని cases లో W by VBR cos theta value వస్తుంది, but theta value is not same. Time is not same, but time formula is same. Time formula anywhere you can write down one thing: width by perpendicular component, perpendicular to river velocity. Velocity component perpendicular to river. Okay, and velocity component along the river will decide what is the drift. Drift leftward or rightward or zero will be decided by the velocities which are along the river. Okay, so then resultant will be somewhat like this, and we will reach the some other point C dash. This is B. Okay, no? So then A to C dash. AC dash will be the path followed by the boat as seen from the ground. So then what the drift value I can write down? The drift value is equal to VBR sin theta minus VRG is the velocity. You want this displacement. So displacement is velocity into time taken. So VBR sin theta minus VRG into time value W by VBR cos theta. Okay, now this is the drift value. All of you okay with all three cases? $is tan theta is equal to no, wait, we will discuss that one. Okay, cannot write down the tan theta value. Drift will be related to angle made by the velocity vector as seen from the ground, and the resultant angle you have to take biology, not theta. Theta is the angle made by the whom? Theta is the angle maintained by the boatman, the person inside the boat. But if you want to include the drift and width are real, means they are from the ground. So you have to take the angle from the ground. If you take the angle made by the boat as seen from the ground, then you can write down this one. Okay, Balaji, don't confuse. So all of you please revise all these three cases. Okay, no? Andaro clarity raavali. And tomorrow I'll discuss some more cases related to river boat. Okay, river boat is little lengthy concept for JEE, so we have to see so many models. First we'll go with the all velocity related, constant velocity. Boat velocity constant, river velocity also constant. Then we'll go for variables. River velocity is variable, boat velocity is variable, boat can accelerate. River velocity may change from one point to other point. So all these things we need to solve. Okay, so that we do one by one. Please all of you go through today's class, revise చేయండి అందరూ కూడా. వీలైతే ఇవన్నీ చూడుకొని ఒకసారి రాయండి. రాస్తే మీకు మంచి క్లారిటీ వస్తుంది. సో రేపటి క్లాస్ బాగా అర్థం అవుతుంది. Okay. So bye everyone. We'll meet tomorrow. Okay, Sanjay, bye. Bye bye.